Section 6.5 is all about the kinetic molecular theory, which is really just a theory that helps us understand what it means to truly be a gas. So before we go waxing all poetic, all you need to know is that there's just basically 4 simple rules that are really a little bit common sense, but that make us really have an appreciation for what is this gas that surrounds us every day. So the first one is the particles of a gas are in rapid constant motion and move in straight lines. So I consider this to be my pool table theory rule. The idea is if you hit one ball on a pool table, it goes in a straight line until it collides with another ball, and then it bounces and bounces, but everything goes in motion until it collides. And the second kind of part of this is that the pressure in the container is due to collisions, meaning the wall of a pool table doesn't know the pool balls are on there until they feel the thud of the ball striking it. And so this theory is all about the fact that these balls don't just have a random trajectory. They're not going to change motion in the middle of their course. You set the ball spinning with an initial impact, and everything is predictable from that point. The second kinetic molecular theory says the particles of a gas are tiny compared to the space between them. And so if you look at the picture here, you can see the liquid molecules and then the gas molecules. There's a whole lot more space in between them in a gas, and that's going to make it so that it's a little bit easier to think about, because instead of having all those intermolecular forces, which are really strong in a liquid and even stronger in a gas, they're not really going to matter in this kinetic molecular theory rule number 2. And so what that's going to do is it's just going to simplify things for us a little bit. In reality, are there attractions? Absolutely, but we can pretend they don't exist for the sake of trying to just think through what it means to be a gas. So the size of the individual molecules that you see are insignificant compared to the total volume around it. Kinetic molecular theory number 3. Because particles are moving so fast and they're so far apart, there isn't a lot of attraction between particles. And so this rule is just saying that if we give these particles time to interact, maybe there'd be more of an attraction. But right now, they're moving so fast, there's just no time. Think about this as like that speed dating, or like, where you press the little ticker and you have like 30 seconds to attract a mate. Come on, that's kind of silly. Everybody's moving so fast, it's hard to get a lot of attraction in there. And so that's the same thing with gases. They spend so much time moving around that they just don't have time to interact with its peers. And then the last rule is, as we increase our kinetic energy, we're also going to increase our temperature. If you think about this when you go work out, you're increasing your energy. You have all this energy that you are just expelling everywhere you go, and you're going to get sweaty and gross. But you know what? Temperature is simply a measure of your motion. As you move more, you're going to get hotter, and that's all this theory is stating. So while these theories might seem complicated, they're not. They're kind of common sense, like, hey, why did I just sweat? It's because I expended a lot of kinetic energy and my temperature was increasing. So read through this section, but then go on and read section 6.6 when you're done with it.